Hello, this is Mr. Collier, and today we're looking at the volume of prisms. So over here we have a rectangular prism because the shape of the base is a rectangle. You can consider this to be the base, or bottom side here to be a base. And actually you consider any of the sides to be a base because the base and a prism basically are parallel to each other. So this side, or this face and this face, are parallel to each other, so we can consider those to be bases. They're parallel to each other and they're congruent, so they're bases. But you can pick anything to be the base, so I'm going to pick the bottom here to be a base, and the volume of a prism, any prism, whether it's rectangular prism, triangular prism, pentagonal prism, is going to be volume equals B, which is the area of the base times the height. So this is area of base times the height. Okay, and you could also consider it to be the area of the cross section. So if you take a cross section, which is like a slice out of the prism, okay, it's going to be exactly the same as the base anyway. So you can consider it to be the area of the base times the height, or the area of the cross section times the height. It's really the same thing. Okay, so I'm going to find the area of the base and multiply by the height here. The area of the base is a rectangle, so the area of the base is just 3 times 4, which equals 12. And here is the height of the prism. Doesn't necessarily have to be up and down. Height is the distance from a base to the opposite base. Okay, so in this case the height is 12. So our volume is going to be base times height, which equals 12 from here, times 12 from the height, which equals 144. And for volume, our units are cubic units. Alright? Now there's also another special formula just for rectangular prisms you might have seen. You could also do this as volume equals length times width times height. So volume equals 3 times 4 times 12, the 3 dimensions of the rectangular prism. And you also get 144 cubic centimeters. Okay, so this works for just rectangular prisms. This works for all prisms. In fact, it kind of works for cylinders as well, as we'll see later. Okay. So the volume is 144 cubic centimeters. Basically what that means is you could fit 144 1 by 1 by 1 cubes inside this block here. Okay, so it's like how much space the whole thing is occupying. So you can fit 144 of them in there. Okay, we're going to go on to another prism. This one is called a triangular prism. If you look at this triangle here, okay, we have a triangle here. We'll call that the base because there's a congruent triangle on the other side and they're parallel to each other. We can't take the base to be one of the rectangles because none of the rectangles have a congruent rectangle parallel to it. Okay, so this is the base. This is the base. And the area of the base equals, well, it's a triangle, so it's going to be half times, and be careful here, this is another base. Half base times height, the small b, is the base of the triangle. So in the triangle, we have base and height are 4 and 5 because they're perpendicular to each other. So that's half times 4 times 5, which equals 2 times 5, which equals 10 square centimeters. That's the area of the base. And then we have to look at the height of the prism. Now don't get confused with this height. This is going to be the height of the prism. So the height of the prism is distance from base to base. So it could be up and down, it could be left and right, it could be forward and backward. The orientation doesn't matter. It's basically distance from base to base, which is this distance. And as we can see, it's actually 10. So the height is 10 centimeters, because that's the distance from base to base. So we use our volume formula now. volume equals area of the base times the height of the prism. Okay, not the height of that triangle which we had before. So the volume equals 10 times, well, 10 is the height as well. So volume equals 100, and our units are cubic centimeters. Okay, so next we're going to do a compound figure, compound solid here. We have like a little house here, but you'll notice that we have a rectangular prism on the bottom and a triangular prism on the top. So we could find the volume of the triangular prism and then add it to the volume of the rectangular prism, but also you could just get the area of this entire base right here, the entire thing actually looks kind of messy. It's already in purple. So we get the area of the entire base, which is in purple, and then we'll multiply by the height of the prism, which is 5. So the height equals 5 because that's the distance from this base in the front and the same base in the back. So that's the height of the prism. We're going to find the area of the purple base here right now. So the area is going to be 6 times 8 for the square part. And then we're going to add the area of the triangle. So the area of the triangle is half times base times height. And the base of, well, the height of the triangle we can see right here is 4. And the base is actually 8 because it's the same as this distance. So if we work all that out, we'll have the area of the base. So that's 48 plus a half times 8 is 4. 4 times 4 is 16. So that is 64 square centimeters is the area of the base. So now we're ready to use our volume formula. Volume equals area of the base times the height. So volume equals, and we got the area of the base, which is 64, times the height, which is 5, and that's going to be 320 cubic centimeters.